Subroutines. What is subroutine? A subroutine is a named sequence of instruction which is present in the particular program which performs a special task. This subroutine can also be called as function or procedure. Subroutine helps in organizing code, promoting code reusability, improving code readability. Whenever a subroutine is called, the program jumps to the subroutine location, executes the instruction, and returns the point of the program for when it's called. So what is it? When a subroutine is called, the program jumps to the subroutine location, executes the particular instructions that is present, and returns the point of the program from where it was called. So now we are going to discuss method call overhead. What is this call overhead? What is the difficulty that we are going to come across? Method call overhead always refers to the additional time and resources which is needed to invoke this subroutine. Might be a method or function. So when a method is called, what are the overheads that is involved is setting up the call, passing arguments, returning results. All these three are overheads which has to be done when you go for calling a method or function. This overhead includes tasks such as pushing arguments, saving registers, managing the call task. Dynamic memory allocation for message and object storage. Object-oriented programming is based on objects. What are objects? Instances of classes. These objects encapsulate data and behavior. So, now, in order to allocate memory for these objects, dynamic memory allocation is used. So, when an object is created, memory is dynamically allocated from the heap to store the object's data. This dynamic memory allocation allows objects to have a flexible lifetime, which enables the creation and destruction of objects as needed. Message passing is a mechanism that is used in object-oriented programming to invoke methods and also to communicate between objects. So when a message is sent to an object, the object's method is invoked to handle the messages. Depending on the programming language and implementation, the message might contain information such as name of the method and arguments to be passed. When you come for this dynamic memory allocation and deallocation of memory during runtime as the object is created and destroyed is performed. This flexibility in memory allocation allows dynamic object creation, polymorphism, and memory management. Dynamic memory allocation comes with additional overhead when compared to static memory allocation. Cost is also comparatively higher, but what is that is when you compare this with static memory allocation, this is more efficient. Now, efficient memory allocation strategy techniques such as pooling, garbage collection, or spot pointers are employed to optimize the memory usage and minimize overhead in dynamic memory allocation. Altogether, subroutine, method call overhead, dynamic memory allocation for message and object storage are important concepts which improvise, organize code, enable code reuse, and provide flexibility in memory management. These concepts are very important for writing efficient and maintainable code in procedural and object-oriented programming paradigms.